So the final section in Tools of Geometry is perimeter, circumference, and area. We're going to take a look at 4 different shapes and the circumference, perimeter, or area formulas for each of those shapes. First, we have a square. Now, the perimeter of a square is equal to 4 times the side length. The area of a square we can find 2 ways. The easiest way is just to do side squared or s squared, or we can do base times height. But because it's a square, the base and the height are always going to be the same. Now notice the markings that we have on the square. Every angle is a right angle, every side is the same. When we look at a rectangle, the perimeter is going to be 2b plus 2h, or 2 times the base plus 2 times the height. The area is equal to base times height, or bh. The next shape that we have is the triangle. The perimeter is simply side 1 plus side 2 plus side 3. The area is 1/2 BH. Notice the correlation between the area of a rectangle and the area of a triangle. Triangles are just 1/2 the size of a rectangle. So you could take 2 of those triangles and it would create 1 rectangle with the same base and height. The final shape that we have is the circle. We can use 2 different circumference formulas, either 2 pi r or pi d. So 2 pi r refers to 2 times pi times the radius, or we can do pi times the diameter. Remember that 2 radii is 1 diameter. The reason why we tend to use 2 pi r more than we use pi d is because if you look at the area formula is a equals pi r squared. So the one thing that is always going to be in a circle formula is going to be the radius. So one of the things that we're going to want to be able to do with geometry and these formulas that we're learning is to apply them to real life circumstances. In problem number 1, it says the botany club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? Well, only one of our 2 rectangles actually shows the dimensions that we need. We're told then that the path is 4 feet wide. So what we need to do is we're first going to establish which formula are we going to use. And since it's a rectangle, we're obviously going to use a rectangle. And then since we're looking at the outside edge, we want to use the perimeter formula. So the perimeter of a rectangle is 2b plus 2h. Now the next thing that we're going to do is we're going to figure out what are the dimensions of the outside rectangle. If we look at the inside rectangle, we see that it's 16 feet wide, and then you've got 4 feet on either side. So what we're going to do is we're going to plug into our formula. We're going to go 2 times the base, and we're going to say that the base is 4 plus 16 plus 4. Then we're going to look at the length of that rectangle, which is 22, and then we know that there's going to be 4 feet on either side of that. So we're going to go plus 2 times 4 plus 22 plus 4. So all of those dimensions are going to give us the inside rectangle plus the path on either side of the rectangle. Work inside the parentheses. We end up with 24 on the first parenthesis and 30 on the second set of parentheses. So then we're left with 2 times 24 plus 2 times 30. 2 times 24 gives you 48. 2 times 30 gives you 60. Add those together, we have 108 feet. So the botany club is going to need 108 feet of edging to be able to do their project. Problem number 2 has us shifting over to circles, so we're going to find circumference. The question is, what is the circumference of the circle in terms of pi? What is the circumference of the circle to the nearest tenth? So we're given a circle that has a 15-inch diameter. And again, first thing we want to do is figure out which formula we're going to use. So we're going to use c equals pi d since we're given the diameter of this circle. Plug in 15 for d, so that gives us c equals pi times 15. We're going to flip the number and the pi around just to put it into proper order, and that gives us c equals 15 pi. This is our answer in terms of pi. Now, in order to find the answer in terms of the nearest tenth, we need to take out the calculators, multiply 15 times pi, and that's going to give us approximately 47.1. Again, with problem number 2, we're going to be looking for circumference in terms of both pi and down to the nearest tenth, but this time we're given a circle with a 4 centimeter radius. So what we'll do this time is we'll choose the formula c equals 2 pi r. We're going to plug in 4 for the radius, which gives us 2 pi times 4, multiply 2 and 4, and that gives us 8 pi. So 8 pi is our solution in terms of pi. Multiply 8 times pi, that's going to give us approximately 25.1, and that is going to be our solution to the nearest tenth. In problem number 3, we're going to switch over to triangles, and we're going to use the coordinate plane to find lengths. So the question is, what is the perimeter of triangle EFG? We're given that point E is 3, 6, point F is 3, negative 2, and point G is negative 3, negative 2. What we can see from the triangle on the coordinate plane is it looks to be a right triangle. So what I'm going to do is I'm going to take a look at the y values and the x values of a couple of the points to determine if it is in fact a right triangle. We look at G and we see that G has a y value of negative 2 and F has a y value of negative 2. That means that they're directly across from each other and a horizontal line connects them. If we look at the x value of point E, we see that it's 3, and point F, we see that that is also 3, so that means that we have a vertical line going in between those 2 points. So the intersection of any vertical line and horizontal line is always going to be a 90-degree angle. So we do know that this is a right triangle. That does make this problem quite a bit easier for us because we don't have to go through a bunch of distance formulas to be able to find what the distances are. So really all we have to do here is figure out what is the distance between 3, 6 and 3, negative 2, and that's just distance on a number line. So we're going to use the formula, the distance for E and F is equal to the absolute value of A minus B. So the distance of EF is equal to 6 minus negative 2. Remember that minus and negative is going to be a positive, so we have 6 plus 2, which gives us 8, and the absolute value of 8 is 8. So the distance between E and F is 8. Now for F and G, because F and G are a horizontal line, that means, again, we're using distance on a number line. So FG equals the absolute value of A minus B. We can plug in 3 and negative 3, so we get 3 minus negative 3, which gives us 3 plus 3, which is 6, and the absolute value of 6 is 6. So now we have lengths of 8 and 6. All we have left is the hypotenuse of the right triangle. So to find that, we can just use the Pythagorean theorem. So remember that the Pythagorean theorem is going to be a squared plus b squared equals c squared, and we know that that's going to be equal to the distance between E and G. So EG equals 6 squared plus 8 squared equals c squared. 6 squared is 36, 8 squared is 64, that gives us 100. We need to remove the square from the right side of the equation. So to do that, we take the square root and we end up with EG is the square root of 100, or EG is equal to 10. So now we have 8, 6, and 10. We just need our perimeter formula for a triangle, and the perimeter of a triangle is S1 plus S2 plus S3, and that means we've got 8 plus 6 plus 10, and 8 plus 6 is 14, plus 10 is 24. So the distance around the perimeter of triangle EFG is 24 units. In problem number 4, we're going to find the area of a rectangle, but in this particular problem, you're going to need some conversions. So you want to make a rectangular banner similar to the one below. The banner shown is 2.5 feet wide and 5 feet high. To the nearest square yard, how much material do you need? So the first thing we're going to do is we're going to change 2.5 feet into yards. Remember that there are 3 feet in a yard, so 2.5 is 5/6 of a yard. 5 feet is 1 2/3 yards, so that is going to be 5/3 yards. Now, all we need to find the area of the rectangle is the area of a rectangle formula. So A equals base times height. So we have a base of 5/6 and we have a height of 5/3. Multiply those together. Remember that when multiplying fractions, we multiply across the numerators and across the denominators. So we end up with 25/18 or 1 7/18 yards. Now, because the question asked us to give us the answer in how much material will you need to the nearest square yard, we're going to round that up to 2 square yards. In problem number 5, we're going to take a look at finding the area of a circle. So we're asked, what is the area of circle K in terms of pi? In this problem, you can see that we're given the diameter is 16 meters. So what we need to do is we need to figure out what is the radius going to be. Remember that there are 2 radii for each diameter, or the radius is half of the diameter. So if the diameter is 16, the radius is going to be 8. Which formula are we going to use? The area of a circle is equal to pi r squared. So we're going to plug in 8 for the radius, and we're going to get pi times 8 squared, which gives us 64 pi meters squared. The next postulate is the area addition postulate. And it's very similar again to the segment addition postulate and the angle addition postulate. It states the area of a region is the sum of the areas of its non-overlapping parts. So what we can do is we can actually take this figure and we can break it down into 3 separate rectangles. We would then be able to find out what are the areas of each of the rectangles, add them together, and that's going to give us the area of that particular figure. And problem number 6 is going to be the last problem that we do in tools of geometry. And what we're looking to do is find the area of an irregular shape. So the directions are, what is the area of the figure? And it tells us that all angles are right angles. We're going to take this irregular shape and we're going to break it into 3 separate rectangles. So you can see that you've got a square with 3 centimeter sides. You have a rectangle with sides of 3 and 6. And then you have a rectangle with sides of 3 and 9. So for the area of a square, we're going to use s squared, and we're going to plug in the side of 3. That gives us 3 squared, which then gives us the area of the square is 9. For the area of the small rectangle, we're going to use A equals BH, and we know that the sides are 3 and 6, so we're going to plug those in. So we get A equals 6 times 3, or A equals 18. We then have the large rectangle, so again we're going to use A equals BH, and this time we've got sides of 9 and 3, and then that gives us an area for the larger rectangle of 27. We're going to take all of those together to find the area of the irregular shape. 9 plus 18 plus 27. 9 and 18 gives us 27, plus another 27 is 54.